Okay, today this is the next episode of BobCAD's webinar series. Today's topic is 3D programming. This is a 3D programming boot camp. Okay, let's see here. As an overview, the goal of today's webinar is to help you get more out of your CAM software by showing you how to use common 3D toolpaths and options. So that's what we're looking for. My name is DePoalo. I do the BobCAD After Dark video series. You can find me on Instagram at DePoalo, or you can always look up hashtag BobCAD-AfterDark. All right, so we're going to be talking about three common cutting strategies, okay? These are the ones that I just want to focus on in today's webinar. I know there's a lot of topics, so I want to talk about Z-level rough. Z-level rough, Z-level finish, and planar are the three most common strategies you'll use in any scenario. Whether you're new to 3D machining or if you've been doing it for a long time, these are your go-to strategies. Z-level rough, you can think of it as a 3D pocket. This is where you remove the bulk of your material. It's going to go level by level. And it's going to follow the contours and the surfaces of the model or surfaces you've selected. Now, Z-level finish, you can think of this as a 3D profile. This is going to follow it's really best for the steep areas or the more vertical walls, okay? This is used to machine vertical walls, tapered walls, or steeper areas of your part. The last one is planar. It's hard to say what planar really, how to compare it to another toolpath, so I came up with facing. It's like facing. When you face off a part, you deck it off and you get a nice consistent finish. Well, that's kind of what planar's like. You go back and forth. Planar is best for shallow areas of your part, okay? So Z-level finish is to remove the bulk of the Z-level rough is to remove the bulk of the material. Z-level finish is to get the more vertical walls, and planar is to get the more shallow areas, okay? All right. Now, the other thing we're going to talk about is geometry selection, okay? This is really important. Are you applying your toolpaths to your model? Are you applying your toolpaths to a single surface or multiple surfaces? How do you contain your toolpath, your boundary support? So we're going to go into details of working on a model, working on a single surface, and using boundaries and different ways you can control where your toolpath is being generated. All right, we're also going to go into detail about toolpath options, the patterns, parameters, leads, and links. I'm not going to spend a ton of time on when and where to use these different values and parameters. I'm going to use a template, and I'm going to apply them to different geometry sets so we can look at the difference. But one of the things that I want to talk about this is, when you're dealing with your toolpath options, you really want to, like, a big tip is to change one setting at a time and then recompute your toolpath. Experiment with different settings so you get more comfortable with what the results are. And then the other thing is to find similarities. These rough patterns, parameters, leads, options, these are consistent throughout the features. There's about 12 different variables that you're going to run into, more or less depending on the strategy, and they're very similar. So we're going to spend some time on this, but more so the application of the toolpath to models and what the differences are, okay? A big aspect of the software is working smarter, and how do you do this? You do this by using what you've learned from one scenario and applying it to another. You can use save and load, you can use copy and paste. I highly recommend you start building a feature library that you can apply for roughing, semi-finishing, and finishing. This way you're not starting from scratch every time. Okay, we'll go through a Q&A section where we're going to open up the floor and talk about questions and answers that everybody has. This way, anything that wasn't picked up, or if there's something we want to go into more detail on, we can do so. And then the last thing is, to learn about the latest in cutting edge CNC programming, call us. Give us a call, 877-262-2231, extension 123. You can find us on Facebook, YouTube, Twitter, Instagram, at BobCAD-CAM, hashtag BobCAD_CAM. Okay, guys? All right, now let's get into it. So let me get out of this here, and let's open up the software. Okay, so the first thing that I really want to talk about is, using, applying toolpaths to a model. Now, here I have a sample part. I have about 10 sample parts that we're going to look at here today. We have our job set up. I have the stock set up. I have my zero set up, and then I have some features. So, when you're starting fresh, like when we're starting new, and I'm only going to go through this one time in this webinar because I want to spend more time focusing on the toolpaths, right? So you have a new part, whether it's at the world or not, you got to create a job. The job is where all your toolpath is generated, right? So we're going to run the stock wizard. We're going to next through the workpiece. We're going to use rectangular stock. There are other stock types, but in this example, we're choosing rectangular. What rectangular does is it just wraps the stock body around the model. Wherever the area of the model is, you're going to have stock. Okay? We're going to advance through this, and this is where you're going to pick your origin. In order to pick the origin, you click on origin, and then you click on one of the snap points, and you can choose any snap point that you want. We auto create snap points for you, or you can use a point or a middle end, any of the snap points on wireframe geometry. So if you add a location, you can choose that. All right? So we have geometry, we've run the stock wizard, now we're able to generate toolpath. In order to generate the toolpath, you right click, and this gives you access to all the toolpath features. You go to a feature, you select your geometry. Okay, when you go to select geometry, you're in selection mode. So you can click on a single surface, you can select all, you can pick by color, you can pick by layer. And as you know, I do recommend sorting geometry by color and sorting geometry by layer. It makes it really easy to select what you want. In this example, we're going to say all. Spacebar to lock in the selection. If we were going to choose a boundary, we would choose that now. This is where we're going to go to our machining strategy. You'll pick a strategy. Next. Now you can next through, or you can go to the Explorer view and pick a tool, set your patterns, go to your parameters. Now I'm going to stop right here. When you are testing out toolpaths, there's no reason to run the accuracy at 5/10. That's a very accurate toolpath. Okay? That toolpath is going to take way too long to calculate, and it's going to separate you from, give me just a second here. All right, sorry about that, guys. We have so many people that are trying to get into today's webinar. For future notice, if you sign up for a webinar and you're not able to get in, we will email you a copy of the webinar. We put it on YouTube, and you'll get a copy to watch it later. So just keep that in mind. This way you can review this information. So again, where I was talking about, one of the options you have here is the machining tolerance. By default, that is very accurate. You do want to loosen this up. When you're calculating your toolpaths, they'll calculate quicker, and it'll be easier for you to see what's happening with the toolpath and not spending as much time with calculations, okay? Another thing to talk about real quick, and again, it's going to be the save and load of the features. A lot of people go, hey, I want to default the depth of cut, the step over, the tolerance. You know, I want to default the tool that I'm using, the speeds and feeds. Like I said, there's about 12 parameters that you can adjust, all right? That is what save and load is for. You save a feature, you load a feature. You copy a feature, you paste a feature. This way you don't have to go through the dialogue every time. Okay, so you're going to go through, when you're starting from scratch, you're going to go through and answer all the questions. Different options do different things. When you're done, you're going to compute, and that's going to update or generate toolpath based off the model. Okay, that's how this works. You right-click, you go to a feature, you select the geometry. Okay, so let me get back to, that's a quick rundown on setting up your stock and loading features. Again, I want to spend more time here is on the cutting strategies. All right, now in this example here, we want to look at Z-level rough, Z-level finish, and planar. And you can see I've created a folder in the tree. The folder has these 3 cutting strategies, okay? Now, in order to generate toolpath for these cutting strategies, I have to select geometry. So I'm going to go to the Z-level rough. There's a little plus sign here, so we know there's no geometry associated with it. We're going to right-click, reselect, and we're going to choose select all. In this case, we're going to choose select all. We select the whole model. We hit our space bar. Now to apply the settings, we're going to right click and choose compute. All right, so this gives us a Z-level rough. This is a 3D pocket. The idea here is to step down. You control the step down, and it's going to remove all the material. Now, another thing that's very useful to do to check for hangout, to see where the tool is going to start cutting, where it ends cutting, is to backplot. Okay, you do have simulation, and there's lots of simulation tools, but what we want to do is right-click on that feature and then go to backplot. This will show your tool in your holder. You can progress through this, you can slide it through, you can play it. What you're looking for, you know, it's not going to do collision checking. What you're looking for is like hangout. You know, you can see that I have plenty of flute to be able to cut this. All right, I got no tool holder issues. The other thing, you can see where it starts. Now in this example, it's starting over on this side. Maybe not the best place for it to start, but that's where it's starting. So you know where the tool starts, what direction it's cutting in. This is a great quick check to see what's going on. All right, so the first one is Z-level rough. This is a 3D pocket. It's going to apply to the geometry that you've selected. Now, when you're generating more toolpath, you want to blank these things out. You don't want to look at them the whole time, right? So we're going to right-click and we're going to choose blank, and that will hide that toolpath. Now, if we click back on the feature, it shows up. So if we want to see it, we click on it. If we don't want to see it, we right-click and we choose blank. Let's look at the next one, all right? We go to geometry, right-click, reselect, select all, spacebar, right-click, compute. This is going to be a Z-level finish. Now, a Z-level finish, like we said earlier, is going to be best for the steep areas of the part. Now, if you look at this, where the surface is more vertical, we're going to get a better finish. As it starts to flatten out, you're going to get a greater scallop, and when it goes flat all together, it's going to ignore it. It's not going to cut the flat areas of the part. So Z-level rough is for pocketing out the material. Z-level finish is for the more vertical areas of the part. The next one that we want to look at here is planar. Planar, sometimes they call it lace. You know, this is, like I referenced to, this is like a facing cycle. It goes back and forth over the part, okay? So this is going to go back and forth over the part. Where this does better, you can see the flat areas of the part, we get nice coverage, nice consistent coverage. As we get to the more vertical areas of the part, we're going to get greater scallops here. Now in this example, I have 2 planars. I have one at 45 and one at minus 45, so it crisscrosses. The reason why I do this is to get good coverage, okay? It's a, you know, you cut it on a 45 one way, you cut it on a 45 another way, you're going to get good coverage. Is that the most efficient way? Not necessarily, but if you're doing pattern work, if you're new to 3D programming, cutting in 2 directions like this will cover all the areas of the part, all right? So that's planar. Let's blank this out. So we got planar here. We got Z-level finish, and we got Z-level rough. These are your most common 3-axis cutting strategies. Now, when we look at Z-level rough, you know, what are some of the options that you have in here? If you go to patterns, and you're going to notice each strategy is going to have patterns, parameters, leads, options. You know, maybe links is in there as well. And all the cutting strategies I'm covering today are in the BobCAD mill standard. These are the mill standard cutting strategies. Okay, we'll do a follow-up webinar possibly in the future on Pro and then Advanced, but these are mill standard. So if you got the 3D standard or Pro, you have these strategies. What you learn about these strategies, you can apply to the Pro strategies as well. All right, so you got cutting patterns, pocket in, pocket out. This is just whether it goes from the outside in or the inside out. Okay, you have parameters, depth of cut, step over, how much it steps down, how much it steps over. Allowances is stock for finish, how much you're going to leave for the next routine because it's rough, semi-finish, finish, right? Machining tolerance, this is the accuracy of the cut. If you make it looser, it's less accurate. If you make it tighter or smaller number, it's more accurate, okay? So patterns, parameters, leads, this is how we're getting into the part. We could plunge, we could ramp, we can spiral. You know, and then you have some options for inside cutting or outside cutting. So when you're making changes, if you're new to this, you just want to do one thing at a time and see what happens, all right? So if you make a change, let's say we go to our parameters. Let's say we change our depth of cut, right? So we change our depth of cut. What we need to do to update the change is we need to compute. So we go compute, and that updates the change for the toolpath, okay? So we changed our depth of cut. If we come back, if we click on the feature, right click and edit, and then we go to our depth of cut and we make it smaller, we compute, and then it updates for the change of that toolpath, okay? So that's how you make changes, and I'm recommending you make one change at a time. Now, one of the things that I want to talk about here, and I'm trying to keep it very concise because there's so much to talk about, but one of the things that I want to talk about here is how I have 3 different features here. I have the Z-level rough feature, I have the Z-level finish feature, and I have the planar feature, okay? Now, in order to save one of these features, you right-click and you choose Save Feature, and you can save it into a directory. In order to load one of these features, you can right-click on the feature or the tree, okay, or the setup, excuse me, and you can go to Load, and then this will let you load in a feature. You can load it in from a directory. So you can save or you can load. Now you can also take a feature and you can copy and you can paste. All right, so you can see how I copied and paste. The other thing you can do too, and this is really cool, is you can copy and paste operations. So I can right-click, copy, right-click, paste. So now I added Z-level rough and I added Z-level finish to this routine. I can go to my planar, right-click, copy, go to here, right-click, paste. So I added Z-level rough, Z-level finish, and the planar. The reason why I show this is sometimes you'll have operations in a feature and you may want to use it in another feature. You can load it from within the feature. You can edit and go to the machining strategies and you can push them back and forth this way. The other thing you can do is copy and paste them like I showed you there. I'm going to reselect my geometry here. I'm going to recompute, and now you're going to see the Z-level rough, the Z-level finish, and the planar are all within that one feature, okay? All right, so that's a little bit about copy and paste. I'm going to go ahead and delete this feature here. All right, and I have this one feature already set up. So Z-level rough for pocketing, Z-level finish for more vertical, and then we have planar for the more shallow areas of the part, okay? So what I want to look at is combining these tool paths to machine this particular part here, okay? So I want to combine them. So I have them all combined in one feature at this point. I'm going to reselect my geometry. So that gives me the tool or the geometry that's going to be applied. Now, here's the thing. Let me go ahead and let me compute this. So I'm going to compute this tool path, and you can see all the tool path is being applied to all the geometry that I've selected, okay? I'm going to remove the tool path. I'm going to reselect, and this time I'm just going to select, here, let me do this. Okay, so instead of selecting all the geometry, this time I'm going to select, you know, a single surface. So I'm going to select just this surface. I'm going to recompute the Z-level rough. Okay, so what happens is with the Z-level rough, even though this is the only surface I selected, the toolpath goes further out than what I expected, right? Okay, does anybody know why that is? Let me throw that out there. If anybody knows why that is, raise your hand. Here, let me reset the hands. If anybody knows why that is, raise your hand. Okay, let's see here. Okay, we got a couple. We got Dennis and we have David. David, do you have a microphone? Dennis has a microphone? You both do. Okay, let me turn you on, David. David, can you hear us?
Yeah.
Okay, so thank you for participating in today's webinar. The question is, why is the toolpath cutting out further? Can you answer that for everybody?
Because of the stock.
Because of the stock, that's exactly correct. So what does that mean? In your own words, what does that mean for Z-level rough?
That it's driven by the stock around whatever geometry you pick.
That's exactly correct. That's exactly what it is. So to kind of, and thank you very much for piping in on that. I'm just going to turn the transparency of the stock up here. So is it fair to say that if I come in here and I change my stock on either side, right? So I add an inch on either side. If I recompute this, what's going to happen? Right? The toolpath is going to go out to the stock boundary. So that's one of the points that, and thank you very much for participating. I may call on you again, okay, bud?
Okay.
All right, thanks. So one of the things that we want to talk about is geometry selection and boundaries, right? In this case, we've selected this surface here, okay, and the toolpath went to the stock boundary, and that's how Z-level rough works. Z-level rough, the toolpath will go to the stock boundary. The other strategies, I mean, different strategies work different ways, but Z-level rough is a roughing routine. The stock is the boundary. The center of the tool will go to the stock boundary with the standard Z-level rough. Okay, so you can see that the center of the tool is going to go to the stock boundary, which is important to understand. All right, now if we look at the Z-level finish, let me blank all these toolpaths out. If we look at the Z-level finish routine, let's go ahead and compute this one. You'll see the Z-level finish routine, and if you hit S on your keyboard, again, we're applying it just to this surface here. The Z-level finish routine is kind of running, it's cutting this surface, but it's also trimming back. I'm not really sure why it's going back over in this area. It's being driven along the surface, but it too is going, cutting more than what we expected it to cut. If we look at planar and we recompute that, you can see planar is going to cut right along the surface here, but because we only selected that one surface, what's going to happen is the tool is actually going to run into the neighboring surfaces. You can see it up at the top here. The tool is going to run into the neighboring surfaces. So again, when you're dealing with geometry selection, what you select is extremely important, okay? And the different cutting strategies are applied as far as like boundaries. They're applied differently. Z-level rough will go to the stock boundary, okay? Z-level finish, and again, I'm not sure why it's cutting around in this area here, but Z-level finish will generally be driven, I have a boundary, that's why. Let me remove that boundary and recompute this. Z-level finish will generally just waterline over the part. Now, one of the things you see me doing here, I'm doing an S for shading. That way I can see through the model. This is pretty important because sometimes toolpath is generated through your model, and it's not apparent because you can't see it. So if you hit S on your keyboard, you can see the shading. You can turn it on and off, okay? So Z-level finish is cascading over that surface. That's definitely wouldn't be the best scenario for a single surface, and planar is running into these other surfaces here, okay? So let me do this. Let me remove and let me recompute my toolpath so I have none on here. And all these red X's, this just means they're blanked out. Let me select a few of these surfaces. So I'm going to grab this one, and this one, okay? If I grab a few of these surfaces here, and let's recompute the Z-level rough, right? The Z-level rough is going to extend out to the boundary, okay? And the boundary for Z-level rough by default is the stock, okay? So it's a good thing to know because what happens a lot of times with Z-level rough is you don't get it to cut around where you want. So the trick for that is to extend your boundary. So if we recompute this one, we can see as we change our stock, okay, the toolpath adjusts for it. The Z-level finish here, let's go ahead and compute that one. Now that we've selected these surfaces here, you can see, here, let me blank this out. We selected these surfaces here. You can see the Z-level finish, it's going to waterline and cascade over it, okay? If we look at the planar, let's compute the planar. The planar is going to run back and forth, and because there's no neighboring surface here, now we're not running into an issue on this end, okay? So when it comes to your 3D strategies, you can apply them to a single surface, you can apply them to multiple surfaces, and you can apply them to solids. But the toolpath is only going to consider what surfaces you've selected. And that's actually a very powerful tool. You can use surfaces to stop the toolpath from cutting in different areas. You can block areas and cap things off. So that's a very, very powerful tool. Now, what you select plays a huge role in what's being generated. To control the toolpath, to control where it's going to go, it's going to be a combination of what you've selected and what some of your settings are, okay? What you selected to drive the toolpath along, what boundaries you've used to contain the toolpath, your top and bottom of job setting, additional surfaces that you may apply to it. So what do I mean by that? So let's kind of, let's recompute so we get nothing here. Let's come in here and select some of these surfaces. So we're going to select these surfaces here. Okay, we're going to compute our Z-level rough. What do we got here? So you can see the Z-level rough is cutting out to it cuts the surfaces that we selected, but it's cutting outside as well because it's going to the stock. So what are some of the ways that we can contain that? Well, we can use a boundary, and one of the things you'll notice is when you have multiple features in the tree, you can see each of them have a boundary option. And then there's a parent boundary. The parent boundary would be applied to all the features, and then the individual operations have their own boundaries in case you want to just use a boundary on one of those settings. Now, your boundary input can be wireframe, but it can also be surface edges. So you can pick around edges that you may want to contain that toolpath to. So I'm going to select some of these. You know, I kind of want to talk about some of the different you can use surface edges. Sometimes you can just pick the surface. A lot of times I use wireframe. So here I selected all those surface edges. If I recompute, now you're going to see that the toolpath is staying inside of that boundary. That's for the Z-level rough, okay? If we go to the Z-level finish and we recompute, now you can see that the toolpath is staying to that as the boundary as well. It looks like on one of these sides here, it's going over the side of the part. So that definitely wouldn't really work for us. So we'd have to look at containing that a little bit differently. If we go to the planar, you can see the planar would be staying inside of that boundary as well. And then we have the other planar here, and that's just going to cut in a different direction. Okay, so one of the options that you have to control the toolpath is going to be the surfaces that you select. Another option that you have to control the toolpath is going to be the boundary that you select. So if we look at our surfaces here, we didn't select these walls on the side here, and when we look at Z-level finish, you can see that it's cutting down onto that other side, right? So if we add these top surfaces to our selection and recompute the Z-level finish, you can see those other areas go away. Okay, so what you select affects how your toolpath is being generated. Your boundary is how you contain, or one of the ways that you contain, where your toolpath is being generated. Now, when we talked about Z-level rough is for pocketing, Z-level finish is for steep, planar is for shallow, when we talk about the shallow areas of the part, you know, maybe I don't want the Z-level finish to try to run down in these areas here because that's wasted movement. and maybe the planer, I don't want it to recut those areas, okay? And I want to pause for a moment, and I do want to talk about Z-level rough. You have inside and outside cutting, but basically it's an offset pocket. Z-level finish, you can cut innermost or outermost, but basically it's a 2D profile that follows the curvature of the surfaces. And planar is a facing cycle where it goes back and forth, right? So if we go to planar, you do have the option to adjust the angle of your toolpath. So I can set that to 0 and recompute, and now you can see it's running down the length of the part. I can set it to 90 degrees, and now you can see it's running perpendicular to the part, okay? I recalculated them all, okay? So you can control the angle of that toolpath. Now, for some applications, I like it to stay parallel to X or parallel to Y, because then you only have X and Z and Y and Z versus X, Y, and Z, for older machines that may have backlash or what have you. You can also get G18, G19 arcs when you run in those planes. So these are things to consider. But again, for today, I just wanted to touch real quick. This is the lace angle, or the angle the toolpath is being generated, okay? So we have one feature, it's associated to geometry. We selected some surfaces that we want to apply the geometry or apply the toolpath to. We have a boundary that we're using to contain the toolpath, so it's staying inside of that area. We roughed it, we did the Z-level finish, we did the planar. So what we want to do is, we don't want the Z-level finish to go all the way down, and we don't want the planar to go all the way up. This way we can utilize those strategies the best way we can. So what we would do is we would change when we go to our parameters, we can change top of job and bottom of job, okay? Now this is something new to the 29, is you've always had the ability to input a value here, but they added the ability to pick the level there, and this I feel is a great feature, because sometimes your origin doesn't match world, and it's difficult to measure what it is that you want. You can go pick, you can pick off the model, and it will measure where it is for you, okay? And then you can adjust it. I think that's a great feature. If we come in here and we go to our Z-level finish, you can see now we're restricting where it's cutting in Z. We're restricting where it's cutting in Z by using a top and bottom of job, and all of these features will give you a top and bottom of job. If you go to parameters, you have top of job, bottom of job, and depth options, okay? Parameters, top of job, bottom of job. So we did this for Z-level finish to limit it so it didn't go any further. When we go to our planar, we're going to say our top of job, we're going to say don't start into a certain level, and we'll recompute that, and now you can see how we can keep the tool down in the shallow areas. So rough is great for pockets, Z-level finish is good for vertical, planar is good for shallow, and you can see how your geometry selection, your boundary, and your top and bottom of job really help control where your toolpath is going, okay? All right, so that's on this particular file, that's about all I really wanted to cover on this file. Before I move to the next file, raise your hand if you have a question about anything that we just covered here. Let's see if anybody's got any questions. All right, we got one. Let's see, Steve. Are you there, Steve? All right, Steve's got a written question. Can you turn your mic on, Steve? No, okay, you can't turn your mic on. Okay, yeah, so what's the question real quick, Steve? "3D programming, how do you get the tool to start off the part and step into the part with default boundary using a 1/2" tool? First cut is 250 wide." So are you asking in roughing? Yes, okay, roughing. Okay, so for Z-level rough, that one's a little more difficult. to handle. With the standard toolpath, you don't get to pick your start point. When you see Z-level rough, you can select your geometry, you can give it a boundary, but you don't get your start point. If you want the tool to start off the part, sometimes you can do that by adjusting your stock, okay? And you can add an amount, and sometimes when you do that, the tool may start over here. But other than that, you don't have, in the mill standard, you don't have control over the start point, okay? In the mill professional, you do have what's called open pocketing or an open boundary with the advanced rough. And then in the advanced rough, that would give you the ability to start off. You can give it a pilot hole. You can give it a pilot hole. You can give it you can say it's an open boundary, work its way in from the outside, and it will do that. Okay. In the standard, there's a limitation there, so you're not going to be able to tell it, hey, start off the part. Sometimes you can get away with it with the boundary, especially if you're doing a male shape. Female shapes are a little bit more difficult to handle. Okay, that's a good question. Thank you for asking it. From here, what we're going to do is we're going to move on. Planer, planer is actually, before I move on, that's a great point. Let's say you want this toolpath to start off the part and finish off the part. Well, one of the things that you can do is you can adjust your surfaces, and that's really what it comes down to. Is the toolpath is being driven by your surfaces. Okay, so let me remove this boundary for a second. All right. What I can do is I can come in here and do a extrude surface, and I can add some amount on this side, and I can add some amount on that side. Okay, those additional surfaces are then added to my selection. Okay, when I update my toolpath now, you can see that the toolpath is going to start and finish way off the part. Now, in this example, I gave way more clearance than really is necessary, but it's to demonstrate the concept of how you can use surfaces to drive where the toolpath is going. So hopefully that answers your question there. All right. All right. So let's keep going. So we learned about geometry selection, we learned about boundaries, we learned about top and bottom of job, and then also using additional surfaces. So let's look at another example here. Okay. So this example here, we have you know, this is, instead of a cavity, we have a male shape. So what we're going to do is, I'm not going to start from scratch. I'm just going to grab the features that I already have. I'm going to copy. Okay, and I'm going to paste them into this tree. So, you know, when you do that, all my settings are going to come over. Okay, everything that I got is going to come over. So I'm going to reselect, select all, spacebar. I'm going to compute my Z-level rough. Now, one of the things that you're going to see right away is the Z-level rough is not cutting all the way around the part. Okay, it's where it's going is it's going to, you guessed it, the stock boundary. Okay, so it's going to the stock boundary because that's the default boundary for Z-level rough. Now, I could incorporate, like if I sketch another boundary here, I could incorporate another boundary, reselect that one, and recompute. And then what it's going to do is it's going to drive that toolpath out to that outer boundary. That's one way for me to get it to start off the part. That may be one way that I would do it. Another way I might do it is to adjust the stock like I've shown you. Okay, so when you're dealing with Z-level rough is going to be contained to the stock. Now let's look at Z-level finish. Let's recompute this. Z-level finish here again, because it carried it over from the other routine. Z-level finish is going to do really bad on our shallow areas, and it's going to do better on our more vertical areas. Okay, if I come in here and I edit this feature and I go to parameters, I can turn top and bottom of job off. I'm going to go to this one, I'm going to turn that off. Let me go ahead and recompute it. All right, so here we can see we have some more toolpath. Let me blank everything out. All right, Z-level finish. You can see on the more vertical areas, it's doing a good job. On the shallow areas, it's not doing as a good a job. On the planer, you can see it does a good job cutting across the top of the part, but really it's not getting past that tangency point. You know, we would really need to drive that quite a bit further in order to really machine that well. Let me update this. Let's go ahead and get into simulation real quick. All right, so we're going to go to next stop here. So the first stop roughs it out. That's what we're left with. We're going to slow this down. This is the Z-level finish. You know, and again, with the Z-level finish, you can give it a smaller and smaller step down to give you a better finish on shallow areas. It just doesn't do it. It's not really designed for that. That's why you come in there and you'll use planer. So you can see that one is going to go around this. You know, and then you can see this one here. It actually does do a decent job of cleaning up the top of it. A lot of times, you know, depending on what you're working on, you don't necessarily want to overthink it, but the combination of these two did a pretty good job of cleaning it up. You know, if we wanted to look at extending that tool path over the top of the edge a little bit further, right? So let's look at planer. How do we get this to extend over? This was the geometry. This is our base boundary or apparent boundary. And then this is the tool path, and it's not really going over the edge. So what we can do here is go to edit, and we look at our options, okay? So each one of these is going to have an options, and the options are going to cover cutting extents, okay? The cutting extents is going to give you the ability to let me see here. I keep getting these messages. I'm trying to get rid of them. But the cutting extents here is going to give you the ability to control. You're going to have options, you know, as far as whether it goes extents or part bottom. Each of them have an option in here, all innermost, or you have, let's see, you have extents or part bottom. So extents goes to a rollover distance. It may not quite be the tangency point, but it does roll over to some amount. What we're going to do here is we're going to change this to part bottom, and we're going to change this one here to part bottom as well, and we'll finish. You can see that by using part bottom, now it's going to go all the way down to the bottom, and you can see we use the boundary, so it's going to extend out to the boundary as well, okay? So that's one of the ways that you can get this to cut further, but again, in this scenario, you're going to have way more tool path than that's really necessary to drive over those edges. Sometimes you want it to go further, sometimes you don't. You can use the combination of the top and bottom of job to come in here and to make some adjustments on that. So I can say, hey, you know, let's pick this edge here. We'll make this maybe 550. We're going to recompute that. So now I can get it to roll over, and then I can have it extend out. Now, in this case, it's extending out to the boundary. I may not want it to go that far out. So what I can do is remove that boundary and recompute. Now you can see that it's, you know, kind of right to the edge of the part. This will give you the ability to have it roll over and give you a decent finish on that edge. So you have your roughing routine, you got your Z-level finish routine, your planer. We may want to go with the Z-level finish. We'll come in here and we're going to edit, again, our parameters for top of job, pick. We'll grab this edge here. You know, you can have some overlap. It's okay. It all depends on the material you're machining and things like that, but you can get some overlap in here, and this way we can clean up our walls, and then we can clean up the top, and that would do a pretty decent job. All right, so let's look at another sample here. So we got this one here. This sample, again, it's similar to the other one, the first one that we've done here. It's just a little bit different because of the taper. This time there's a taper going down in this direction, okay? So we're gonna paste our cutting feature. We're gonna select all our geometry. We'll go ahead and compute our rough. This is gonna give us our rough routine to rough out our geometry. We'll do our Z-level finish. Now, the Z-level finish, let's look at some of the settings here. I mean, of course, we don't want it to go around the outside of the part here. So one of the things we can do for our boundary, we can right-click, reselect, right-click on this edge. You know, you can go over an edge and right-click, and it will give you constant Z or loop as an option. So in this case, we're going to choose constant Z, spacebar to lock it in, recompute our toolpath, and now we can bound it to the inside versus, you know, kind of clicking across through those like we did before. Now again, this has our depth settings in here, so we can, you know, edit our depth settings. We can unlock them, recompute. Let's go ahead and blank this out. This again gives you another example of where Z-level finish is doing a much better job on the vertical walls. Then as we start to get into these shallow areas, it really just doesn't do a very good job for that at all, okay? So what we want to do is we want to apply, like we talked about, the planer. So the Z-level roughs it out. The Z-level finish is going to do the more vertical walls. And, you know, again, we can use edit parameters. So we're going to go to parameters, bottom of job, pick. You know, we can grab, you know, maybe this floor here. Okay, that's 550. We can recompute, and that will give us the toolpath just to get in that area. Now, and again, I'm using, like, as I start to refine this, I can go to, let's go to my step down, for instance. You know, I could make this a much smaller number, you know, and that's going to come in there and tighten up our toolpath quite a bit, okay? So, but when I'm first working it out, I kind of want to keep everything loose. This way I can see what's going on and not spend a lot of time in calculations, okay? So this is going to do the more vertical area. If we go to the planer and we recompute, you can see this is going to do the shallower area of the part, okay? And again, you come in here, you edit, you go to parameters, you can change, pick top of job, you can come in here and change where you want it to be. You know, we're at 550 here, so you kind of get the idea of how that works. Let's see here. Something happened there where it didn't like what was going on a little bit. It's probably right along this surface here, so we might move that up. And again, you know, things, you just work with the settings. If you're not getting the result that you're looking for, you go back, you make a change, you update your toolpath. And this is kind of how you work your way through the process in order to get what you want, all right? And then we could do another planer here. So this is just another example like the first one with more of a taper. You may decide in this example that, you know, hey, let's, instead of running at a 45, you know, let's go at 90 degrees. A lot of people like to run down the length of radiuses like this. It's faster to run down the length versus cutting across, but you can definitely cut across the part as well. It's just you know, programming a part, seeing the results, remembering the settings that you used and applying them to future jobs, saving these features, copying and pasting them, and using them as you get into more and more complex work, okay? So let's take a look at another one here, okay? So here we have tapered walled surface. We have this little cutout here. We got a bunch of fillets. Another really good good example of how to apply the standard toolpaths to this. So we just right-click, paste. We'll go to geometry, reselect, select all, spacebar. We can compute our roughing routine. This is going to come out and rough out the most of the material. We can come back to our Z-level finish. Z-level finish, I have getting these more vertical areas of the part. Again, it's using the settings that I had in the last one, so we can kind of drop that down a bit more. We can uncheck that, recompute that. All right, this one here, if we go to planer, let me go ahead and edit that too. So we'll go top of job, finish, we'll compute. You know, planer is going to go back and forth. So, you know, you're going to start using the different boundaries to contain the toolpath, use the different levels to contain the toolpath. You know, this one, it's going down further than I want. So what could I do to stop it? Well, I could use a boundary to stop it, you know, or I may just come in and use my bottom of job, Z-level finish, bottom of job, pick this edge, finish, compute. And you notice that when I edit a single operation that's in a feature with multiple operations, I don't compute at the end, because then that computes all of the toolpaths. So I don't go from the wizard, I don't hit compute, because that computes all of the toolpath. I finish the wizard, and then I go to the individual one, and I compute the toolpath from there. Okay. All right, so what I'm going to do is I'm going to take a quick break here for just a second. Not really a break, I just want to throw a poll out here. I have a couple polls here. Probably should have done this a little sooner, but let me go ahead and launch this poll. I just want to get a better idea of, you know, what versions of the software people are using. So, because a lot of the features that I'm showing right now are found in the classic versions of BobCAD. This would be version 24, 22, 23, 24. These versions would be limited to just these strategies. As we get into the newer software, you know, 26, 27, 28, 29, you're going to find that the Mill Professional offers, you know, 6 additional strategies that people can utilize. Okay, so I think I'm just about 68 voted. We'll give it another second or two. We'll give it a minute and see how it goes. Now, V5, BobCAM and BobCAD-CAM, these products mirror each other. So if you have V5, a lot of the settings that I'm showing you here would be the same. These are the mill standard settings. These are very basic. They're easy to get up and running. This is a 3D boot camp, and the idea here is to understand the basics of the 3D machining, which strategies, what they do, and how to edit them. And what you learn from the basics, you can apply into the more complex. So we got 81% voted. Give it just another second here, but that's going to be just about done. I'm going to go ahead and close that. It looks like we have the majority of our users here running the version 29, so that's great news. Really good news. So let's go ahead and go to the next one. The next thing that I want to kind of do real quick, guys, if you don't mind, I'm just going to launch the next one. I want to find out how long you guys have been using BobCAD. Are you new to it? Have you been using it for just a short period of time? Have you been on the system for a long time? I just want to get a better idea of the user base that I'm working with. We got 55% almost done here. Doing pretty good. It looks like we have a pretty decent group between veteran users that have been with the BobCAD for a long time, and then also a lot of newer users that are just getting started, which is great news. You know, if you are a newer user and you haven't seen BobCAD After Dark, I highly recommend you guys take a look. There's lots of good videos on there, and it's a good way to connect with me. Also on Instagram at Al DePoalo, A-L DePoalo. Yeah, Jeff, I started on version 15 myself, so I'm with you. All right, let's close that down. Thank you very, very much for everybody participating. The next question that I have for you guys, real quick, a little housekeeping, no big deal. Are you on a support plan? Are you current with your support plan? Are you on a support plan? You know, support is a big part of how we take care of you guys, and you know, whether you talked with Sean or Darren or you know, there's a bunch of guys that are down there, Mike or myself or Walter, you know, so just seeing who out there is on a support plan. We'll just let this run a little bit longer. Support is really important. If you're not on a support plan, you know, please be on a support plan. It's important to us, and it's how we can service you guys better. So we'd appreciate it if everybody gets current on their support. All right, I'm going to close the polls now. Looks like most of you are, so that's a really good thing. All right, so moving forward. Okay, so we got our Z-level rough to rough this out. We got our Z-level finish. This is getting more of the vertical walls. Again, it shows how the flat areas of this part are really not applied, and then we have our planer to go back and forth, and we can do our planer in the other direction to go back and forth. So using these very common strategies, you know, you're able to clean up these areas of the part. And this is another really good example with the planer, how where it's more vertical, it doesn't really do the best job. This By doing it in two directions, you can do a good job of cleaning it up, and also in here. Let's talk about a little detail work here. I don't want to spend really much time on the CAD, so what I'm going to do is just select off the model. If I pick this surface, so I want to set a boundary, okay, so right-click, reselect, I'm setting a boundary. If I want a boundary to this surface right here, I can pick that surface and I can apply that toolpath just to that surface. So you can use a surface as a boundary. If I remove that and I reselect, you know, what happens if I select a few surfaces? I probably got the bottom one too. What happens if I select a few surfaces and I recompute? You can see that not so much the same result, okay? So sometimes you can get away with a surface selecting as a boundary. It can just get that one boundary. When you start selecting multiple surfaces, you tend to run into issues as a boundary. A lot of times what I would do is select around these edges. Now another trick I'll do is I'll turn the shading off because it makes it a lot easier to select just the edges that you want to work with, okay? So here I have those boundaries. I can recompute this. You can see that that cleans up quite a bit. I can come back and recompute this one. Oh, I'm sorry, I didn't select the boundary for that one. But I could do that where I could, you know, use the boundary. Same thing, do a crisscross pattern in order to get it to clean up those areas of the part, okay? All right, very good. So that's a little bit about this file. I mean, another thing that I want to touch on real quick is that if you can combine both 2D and 3D toolpaths as well. This boot camp is not about 2D toolpaths, but if you needed to come in here and face off that part, you could load a 2-axis routine. If you wanted to use a ball mill and just profile and walk in to put that radius there, you can do that as well. A tapered mill, you can combine both 2D and 3D strategies. Okay. All right. Let's look at another file here. So we got 5. Let's go to 6. All right. So here we have a more, you know, very vertical. We got a radius on top. How is our toolpath going to work on this one? Is it going to do a good job? What do you guys think? Paste feature, select geometry. All right, so we rough it. What's going to happen? It's going to rough out the bulk of the material, right? No big deal. It's going to rough it out. We go to finish. All right, let me blank these out. Let me edit this feature. Turn this off. Turn that off. Okay, so let's compute this one. Again, this one's going to do a good job on machining the more vertical walls, but it doesn't do a good job on the flat areas. And one of the things that you'll notice too is you can see that this toolpath is linking right along this surface here, and that's going to leave a mark, you know. So one of the things we would do is we would stop it from cutting down further. If we wanted it to run around the part as well, what we would do is create another feature for it. That's what I would do. Use one Z-level finish for one area and another Z-level finish for another area. When you get into linking in these scenarios, sometimes the tool is going to go, you know, when you're going from a group, like this would be a group, to another group, you can run into issues with that. So that's just something, something that you guys need to be aware of. Okay, let's look at our planer here. Let's compute this one. Planer is going to go back and forth. Again, we got a lot of wasted movement there. Let's look at containing that a little bit. Let's go to this circle here and compute. So if we go to that circle there, you can see it contains it, but it's also cutting down inside of here. And we would have removed the bulk of that material. Let's go ahead and reselect and grab this inside boundary too and recompute. So now we have an outside and an inside boundary, and what happens? It still links right across, and that's true. That's what happens with the standard planar toolpath, is if you have an outside and inside boundary, what it will do is a direct link. And you'll see this sometimes where it comes up. So unfortunately, there isn't much you can do as far as boundary control on that one. We may be able to, let's see here. Let's go bottom of job, pick. Let's grab this edge here and compute. We may be able to trim it out with a bottom of job or a top of job. Sometimes you can get it to not cut an area by using a top of job. But realistically, this particular strategy for cutting this area, we don't need it to cut this area at all. Our Z-level finish is going to do a really good job on this. We just need to step it down. And that's the other thing that you find is, you know, as you start working with these strategies more and more, it's going to be easier to know when is a good time to use it, you know? When is a good time to use this strategy? And it's by going over and using them. I'm using the same settings on multiple parts and I'm seeing what I'm getting. And then that way I kind of can predict, you know, predict what it is that I'm working with. All right, so we got Z-level finish, we got planar, we got planar. This one here, really what I would look at is some of the other strategies, probably a radial, or I would do this just with Z-level finish, okay? But today's webinar is about Z-level rough, Z-level finish, and planar. And again, understanding the strategies and the way that they work. Let's see, what do we got? We got this one here. Here's another, you know, more spherical or round type shape. You know, so when you're dealing with these types of shapes, paste, you know, you kind of know what you're going to get. You know what the Z-level rough, it's going to rough out the bulk of the material. Okay, you know that if it doesn't go around the part like you see here, what do? You adjust the boundary. Okay, if we go to Z-level finish, same type of scenario, we know on the shallower areas of the part, here, let's blank this out, blank. Okay, so Z-level rough, we're missing these sides here. Z-level finish, you can see it didn't, well, I have my bottom of job, so I have to adjust the bottom of job to get it to go all the way down. If we go to our planar, we'll compute this guy. You can kind of see here where this time it trimmed it out. Let's go, okay, so let's not get ahead of myself. Let's go to Z-level finish here, turn that off. Let's go to planar, turn this off. All right, finish. So if we compute this one, this is going to go all the way down to the bottom, right? Okay, Z-level rough. What do we do to adjust this? Well, what I would probably do is just go to the stock, you know, and make sure to offset it so there was enough room for the tool all the way around, okay? And recompute that. And now you can see that it's cutting all the way around the part, okay? Or I could use a boundary like we had talked about before. The Z-level finish, you know, this one, there's not much to do here. It's kind of cutting in those areas. Maybe I want to use the planar, or a radial would probably be a good option here. But if I wanted to, you know, limit it to just kind of this area here, again, I would go to my top and bottom of job. So I could say top of job, start cutting here, bottom of job, just let it go down to the bottom. And you can see how, you know, I can control that. If I go to planar, okay, this one here, like we talked about before, you don't have inside-outside boundary control. So if I wanted to do from here to here per se, I'm going to get a direct connect over the top of it. See how it just goes over the top of it. But what you can do to trim out the tool path from running over the top of it is to change your top of job. So now you can say, all right, top of job minus some amount, finish, recompute. Now you'll see it will jump up and jump over, so that way we're not cutting that area of the part. So you can use top and bottom of job to control where it starts cutting and where it ends cutting, okay? All right, let's look at a different one. So we did this one. Okay, so here we have another routine, same scenario. We're going to paste this feature in. We're going to reselect our geometry. We'll compute our rough. That's going to rough it out. We're going to compute our finish. That's going to give us our finish. We're going to do a planar. That gives us a planar. We're going to do another planar. That gets us another planar, okay? Let's blank out the tool path. So we got our rough to rough it out. We got our Z-level finish for our more vertical walls. And you, again, as it gets really shallow, we're losing area. We go to planar. This one looks really kind of weird because of my top of job right now. So we'll just go to the other planar. And here you can see you got your 45-degree cut, okay? So again, applying the same strategies. We know where our strengths are. We know where our weaknesses are. The last one we're going to look at here is, let's see. Well, We got this one. Again, it's the same concept. You know, this one I don't have a job tree set up for. Let's see what we got. What's 10? All right. This one I don't have a job set up for either. All right. So we'll just run this through. Origin. Okay. Paste. Select geometry. Compute. Gives us our roughing routine. Compute. Gives us our more vertical walls. Compute. Gives us our planar back and forth, but that's got the weird top of job. And then compute will give us our regular planar. Okay, we can blank all these features out. So we got our planar, we got Z-level finish, and we got Z-level rough. And this is another good example. Again, we wouldn't necessarily want it to link there. If we had different cavities, we would look at it a little bit differently. Okay, so I'm getting ready to open up to the Q&A. I know we're at 2:06 here, so we're running a little long. Hopefully you guys don't mind. I want to ask another 2 groups of questions for you, and then we'll be done with the polls. I'm interested in what brand CNC machines you guys run. Are you running Haas, running Herco, Prototrax? What do you guys have? Not a big deal. It just kind of helps us understand post-processor demand. Haas is generally some of the more common machines that we run into. We got a good portion. We'll let it run a little bit longer before we close it, but it looks like Haas is common. Southwest Industries, the Prototrax seems to, we got a group there. We got some Mazaks, but a lot of other machines, and there are a lot of other machines that are out there. So probably in the next webinar, I'll throw a few others in there so people can choose. I'm going to go ahead and close the poll now. All right, the next thing that I want to do is I want to just get a quick poll on training. What kind of training works best for you guys? Now, I know me personally, I like working with someone one-on-one who knows what they're doing, and then I like to ask them to do something and see how they've done it, and then do it myself and kind of pick apart what they've done, and kind of like one-on-one training really is what I've done the best with. But I know I do a lot of video training myself. I watch a lot of videos myself. I've been to a few seminars. I like seminars for more the social aspect of it. You get to meet and talk to somebody and shake their hand. It's more personal that way. But just trying to get an idea of what kind of training you guys like most, what's most effective for you and for your staff. I know for me, I'm on my smartphone. I got my Samsung Galaxy, what is this thing? Edge, Galaxy Edge. I'm always watching videos on my phone. So I appreciate all the feedback that you guys have from there. We'll go ahead and everybody's almost done voting, but we'll give it just another second, and it's closed. All right, cool. Very good, guys. Thank you. Thank you so much for the polls. All right, so I want to open it up to questions at this point. There are a lot of questions that came in. There's only one of me that's been driving the webinar today, so I kind of wanted to focus on the material first. Now that I've focused on the material, I want to open it up to some questions and see what kind of questions you guys have or what I can answer for you. We'll go all the way back to our first part here, and we'll see what we got. So Tom has a question about simulation, XY orientation for simulation. I set up the part in the stock wizard and rotate X and Y, then I go to simulation and X and Y doesn't match up. So I'm not sure what exactly you're dealing with there. What I'm going to do is I'm going to turn the posting off on this feature. Okay, I'm going to load another setup into the job. I'm going to edit my setup. In this setup, I'm going to make you know, I don't know, let's make it on this end of the part like this, okay? So we're going to go origin, I'm going to pick this back corner, the X direction is going to be this way, and I'm going to flop the Y direction. So this is my setup for that part, okay? I'm going to take all of my features here, I'm going to copy, I'm going to paste, I'm going to reselect, and I'm going to compute. All right, so this tells me about my top of job setting. what this is, it's probably from my pick. I'm going to make this 0 and compute, and that will solve that. All right, so I have this toolpath set up from this machine setup location. This feature is turned off. When I launch simulation, that 0 should match the 0 in the setup. But I think this may be what you're talking about. Tom, if you're still with us, let me see here. You can see that top is no longer here. Top is no longer matching. Let's go to workpiece show. Let's go to stock transparent. Okay, so if I go to a top view, the top view still matches the top view of the part. So I don't know if that was the question that you had, or what that might be. Like maybe you brought your part in and it was rotated and you aligned your 0 to it, and you were expecting for that 0 to match the top view in simulation. The top view matches the top view of the world coordinate system. That's what it matches. So when you're on one side of the part or another side of the part, it shows which side it is in reference to 0. If you want to eliminate that, you can move your part to 0 and then have your top view align with your part, and then that way when you go to simulation, everything else aligns. And that is the workflow that I use myself. I always align the part to 0 first. Sometimes if it's really awkward in car position, then maybe I would handle it differently. But whatever the orientation of the part is to world is the orientation that that part will be in simulation. All right, so hopefully that helped you. What is the best way to create a surface after you extrude curves and create, say, a box with just 4 sides? What is the best way to create a surface after you extrude curves? I'm not sure what you're asking there, John. You may want to email me. My email is al@bobcad.com. Just reach out to me and we can get together on that and see what we have going on. Let's see here. How do you get the tool to start off the part? We talked about that, Steve. You use the surface extension in order to get the, you use the geometry. You drive with the geometry. So you use the geometry in order to get the tool to start off the part. In the pro tool paths, there's some other tricks, and then in the advanced surfacing, there actually are tool path extensions where you can just extend it off the part. Let's see here. What else do we have? How do you pause for each feature for a manual tool change? John, how you pause for a tool change is in the post processor. When you do a tool change, let's see here. Let's go to verify. So we're going to go to, let's go to tools, verify tool assignment. I have 2 different tools here. I have an end mill and a ball mill that I'm using. Let me just delete this. If I delete setup, okay. So if we go back to here, if I post this up, let me get a post. Okay, so if I post this up, what you're going to see, I don't know why I have them all turned off. Hold on. And post. If I post this up, you're going to see that there's a T1 M6 at the tool change for the first tool, and then when it goes to the second tool, there'll be another T1 M6 wherever it is, or T2 M6. What you do in the post processor is, instead of it saying T1 M6, T2 M6, then you just put an M01 or an M00 in there. It's really easy to edit. Yeah, I mean, I guess you don't even need the M6. You can just do T1 and then M03, or I'm sorry, M00, stop, change your tool. You manually change your tool out, hit cycle start, and go. So that's a posting question. There's a lot of code in this 3D stuff, so it's hard to show those blocks, but that's really easy to accommodate. If you have any questions about it, just email your post to support and tell them what you need, and they'll take care of that for you. All right, let's see. Let's see what else we have. Is backplot only available in 29? Backplot is only available in 29. Backplot is a new feature. It's available in BobCAM v6 as well, but it's a new feature that we added so that you don't have to launch simulation. This is a great tool, like I talked about, for Hangout, for Start Point. You can really see what's going on, so it's really easy to you don't, like if you have bigger 3D models, you don't have to launch simulation. It's just real quick and real simple. So hopefully if you're not running 29 Alex, I would recommend you do so. Let's see what else we got here. Pencil tracing. Yes, we have pencil tracing in the Mill Pro software, and in the next, when I do an advanced 3D webinar, we can talk about that one. All right, let's see what else we have. How do you paste for each feature for manual tool change? You do the same thing. The features are the features. So when you want to pause, I'm sorry, not space, it's pause. When you want to pause, you just do it in the post processor. It'll post an M00, M01, whatever you want it configured to, and you'll handle that. Can I cut a small area of a single surface to repair for damage? Yes, Donnie, you can do that. The best way to do that is just by creating a boundary. Like we've talked about, you can use your surface edges. You can just sketch a circle. You could do a square, whatever the case might be. In this case, I'm just going to select this surface here, this circle, and I'll recompute that. Now you can see there's just a little tiny tool path that's cutting inside of that boundary. So hopefully that answers your question on that. Only rotate X, Y, keep Z same. Part will be 90 degrees at orientation in sim. Yes, it will. Tom, that's because the part 0 matches the world 0, the 0 of the drawing. How do you enter additional moves manually? I'm not sure what you mean by editing additional moves manually. If you want to edit your program, you post up your code, you bring it up in the editor, and then you start editing it. And then you can edit in whatever blocks of code that you want. In our mill turn application, we do have an MDI programming block that allows you to create custom blocks of codes that are inserted throughout at the beginning of a tool change, after a tool change, or at the end of a feature, but that hasn't made it over to the milling or turning side of the software as of yet. Okay, so you just edit it in an editor. Let's see here. Were you able to look the file I emailed you the other day? I was wondering if you knew why it had that glitch. Mark, I'm not sure which file that was right off the top of my head. You know, we can get together after. Do you know what the file name is? I'm not sure which file it is or what the glitch was that you're running into. But you know, I'm more than willing to work with you to go through whatever it is. Okay, so hey, thanks for showing up for today's webinar. So, you know, I really appreciate everybody spending some time with me here today. This will all be in the video. Yes, George, everything should be in the video. If you know me and my videos, I generally don't edit them too much, so they should be in there. But if you guys have any other questions, let's get them done quick. Otherwise, we're going to wrap it up here today, you know. My Predator editor always read only. Do I have to move to my desktop to editor? There's a setting. If you're in read only, there's some settings that you have to do. Run as administrator. There's some simple things that you can do to get it out of read-only. It's not something I work with every day. I've experienced it myself. If you just email or call support, or just email support@bobcad.com, let them know that your Predator is running in read-only. They'll go ahead and take care of that for you. I'd like to watch the next webinar. Can I receive automatic emails to register? George, I don't know how they're working the list on this, whether you get an automatic invite. I know anybody that registered for today's webinar will get an email of the video, and otherwise we generally email people quite a bit to let them know what's going on. So I'm sure you'll get an invitation for an email. What version of Predator was that I just showed? I think it's 6 or 7. Let's see here. About Predator 2005. I think this is 7 is what they call it. It's that we've had the same version of Predator for a number of years. There's a standard, and then there is, I think they call it Predator Pro, which gives you the backplot and the simulation and color coding. Sure, no problem. All right, any other questions here as we wrap up? You know, again, I really appreciate everybody taking time out of your day to spend with me here today. I was really excited about today's webinar. Hopefully I was able to leave it all on the table and convey everything that I wanted to. I tried to keep it pretty simple for you. So if you guys have any feedback on the webinars, you can always email me. My email is al@bobcad, al@bobcad. Any feedback that you have or things you'd like to see covered. Other than that, I mean, I really appreciate everybody showing up, every single one of you. I'm sure a lot of you I've spoken before. If I haven't, I'm sure I will speak with you again. Let's see here. Steve's got something. Can you turn over to the examples with many radius section? I often want to machine only one section, which are not ending in a straight Z level. Angle, range, and boundaries. Yeah, Steve, I think what you're talking about is, let's see, this file here, and you had some questions about you know, how you can target single surfaces or how you can keep the toolpath in one area. Today's agenda is really mill standard strategy, so you kind of are limited. You generally get an overlap is how you attack it, you know, by using top and bottom of job. If you want to, if you don't mind me asking, Steve, what version are you running? Is it 29? Because there are some changes we made to the trimmer that deals with angle ranges. Yeah, so you may want to just email me over the file, al@bobcad.com, and you know, I'll see what I can do to show you different ways that you can attach it. If you guys are on Instagram, definitely check me out on Instagram. It's Al DePoalo, is at Al DePoalo, hashtag BobCAD-AfterDark. You know, if you guys are doing well with the software, make sure to post on Instagram or Facebook or YouTube. You know, we like seeing the good stuff out there. George, when is version 30 next? I don't know what the release date is on 30. If you've been with us for a while, we generally have pretty consistent releases, so you should have a good idea of when we have something coming out. I know we're working on some really awesome stuff. We have some really cool features that we're going to be adding into the software over the next couple of years that is really excited for me as a longtime BobCAD user, and for you as a BobCAD user, you should be excited too. So stay tuned. We'll keep you posted on that. Any last minute questions before I shut it down? No. All right, I think that's it. Thank you so much for your time today, guys. I look forward to seeing you in the next webinar. Cody usually does these webinars, but standing in for him this week, he was at the SolidWorks World. He was at SolidWorks World out in LA, so lucky for those guys. So yeah, again, I appreciate every one of you and your time and your questions. You've been a good group to work with, and I look forward to seeing you in the next webinar. Thank you so much, guys.